Learning objectives. At the end of this topic, you will be able to discuss about lightning, understand the production of static charges on rubbing, explore how charges are acquired on different objects, understand the working of an electroscope, understand how accumulation of charges in clouds causes lightning, explain the precautions which need to be taken during a thunderstorm, understand the working of a lightning conductor.
We've read about winds, storms, and cyclones. Yes, I've heard about the great tsunami disaster. You learned that cyclones can cause a lot of damage to human life and property. You also learned that we can protect ourselves from these destructive phenomena to some extent. In this chapter, we shall discuss two other destructive natural phenomena. These are lightning and earthquakes. We shall also discuss what steps we can take to minimize destruction caused by these phenomena.
We have seen sparks on an electric pole when wires become loose. This phenomenon is quite common when a wind is blowing and shaking the wires. You might also have seen sparks when a plug is loose in its socket. Lightning is also an electric spark, but on a huge scale. In ancient times, people did not understand the cause of these sparks. They were therefore afraid of lightning and thought that the wrath of gods was visiting them. Now, of course, we understand that lightning is caused by the accumulation of charges in the clouds. We need not be afraid of lightning, but we have to take precautions to protect ourselves from the deadly sparks. The ancient Greeks knew, as early as 600 BC, that when amber is a kind of resin, was rubbed with fur, it attracted light objects such as hair. We have seen that when you take off woolen or polyester clothes, hair stands on ends. If we take off these clothes in the dark, we see even a spark or hear crackling sound. In 1752, Benjamin Franklin, an American scientist, showed that lightning and the spark from your clothes are essentially the same phenomena. However, this realization took 2,000 years. Let us perform some activities to understand the nature of electric charges. Take a used ball pen refill and rub it vigorously with a piece of polythene. Bring it close to small pieces of paper. Take care not to touch the rubbed end of the refill with your hand or with a metallic object. Repeat the activity with small pieces of dry leaf, husk, and mustard seeds. We can observe when a plastic refill is rubbed with polythene, it acquires a small electric charge. Similarly, when a plastic comb is rubbed with dry hair, it acquires a small charge. These objects are called charged objects. In the process of charging the refill and the plastic comb, polythene and hair also get charged. Let's perform a simple activity. Inflate two balloons. Hang them in such a way that they do not touch each other. Rub both the balloons with a woolen cloth and release them. Now let us repeat this activity with the used pen refills. Rub a refill and place it gently in a glass tumbler as before. Bring an inflated charged balloon near the refill and note the observations. Let's summarize the observations. A charged balloon repelled a charged balloon. A charged refill repelled a charged refill. But a charged balloon attracted a charged refill. This indicates that the charge on the balloon is of a different kind from the charge on the refill. It is a convention to call the charge acquired by a glass rod when it is rubbed with silk as positive. The other kind of charge is said to be negative. It is observed when a charged glass rod is brought near a charged plastic straw rubbed with polythene, there is attraction between the two. The electric charges generated by rubbing are static. They do not move by themselves. When charges move, they constitute an electric current. We know that the current in a circuit, which makes a bulb glow, or the current that makes a wire hot, is nothing but a motion of charges. Let's perform an activity. Take an empty jam bottle. Take a piece of cardboard slightly bigger in size than the mouth of the bottle. Pierce a hole in it so that a metal paper clip could be inserted. Open out paper clip. Cut 2 strips of aluminum foil about 4 centimeters into 1 centimeter each. Hang them on the paper clip. Insert the paper clip in the cardboard lid so that it is perpendicular to it. Charge a refill and touch it with the end of the paper clip. We can observe that aluminum foil strips receive the same charge from the charged refill through the paper clip. The strips carrying similar charges repel each other and they become wide open. Such a device can be used to test whether an object is carrying charge or not. This device is known as electroscope. Thus, we find that electric charge can be transferred from a charged object to another through a metal conductor. The process of transferring of charge from a charged object to the earth is called earthing. We have learned that during the development of a thunderstorm, the air currents move upwards while the water droplets move downwards. These vigorous movements cause separation of charges. By a process not yet completely understood, the positive charges collect near the upper edges of the clouds and the negative charges accumulate near the lower edges. There is accumulation of positive charges near the ground too. When the magnitude of the accumulated charges becomes very large, the air, which is normally a poor conductor of electricity, is no longer able to resist this flow. Negative and positive charges meet, producing streaks of bright light and sound. We see streaks as lightning. This process is called electric discharge. During lightning and thunderstorm, no open place is safe. Hearing thunder is an alert to rush to a safe place. After hearing the last thunder, wait for some time before coming out of the safe place. A house or a building is a safe place. In case traveling by car or by a bus, it is safe to be inside with the windows and doors of the vehicle shut. Let's discuss about the do's and don'ts during a thunderstorm. Open vehicles like motorbikes, tractors, construction machinery, open cars are not safe. Open fields, tall trees, shelters and parks, elevated places do not protect us from lightning strokes. Carrying umbrella is not a good idea at all during thunderstorms. If in a forest, take shelter under shorter trees. If no shelter is available and you are in an open field, stay far away from all trees, from poles or other metal objects. Do not lie on the ground. Instead, squat low on the ground. Place hands on knees with head between the hands. This position will make you the smallest target to be struck. Lightning can strike telephone cords, electrical wires and metal pipes. During a thunderstorm, contact with these should be avoided. It is safer to use mobile phones and cordless phones. However, it is not wise to call up a person who is receiving your phone through a wired phone. Bathing should be avoided during thunderstorms to avoid contact with running water. Electrical appliances like computers, TV should be unplugged. Electrical lights can remain on. They do not cause any harm. Lightning conductor is a device used to protect buildings from the effect of lightning. A metallic rod taller than the building is installed in the walls of the building during its construction. One end of the rod is kept out in the air and the other end is buried deep in the ground. The rod provides easy route for the transfer of electric charges to the ground. The metal columns used during construction, electrical wires and water pipes in the building also protect us to an extent, but do not touch them during a thunderstorm. Summary. Let's summarize the topic. Electroscope is a device used to test whether an object is carrying charge or not. During thunderstorm, the air currents move upward while the water droplets move downwards. Lightning conductor is a device used to guard buildings from the lightning. Earthing is the process of transferring of charge from a charged object to the earth.